I think we're also hitting maybe a little bit a wall in NLP, where maybe just using text alone is not enough. Even when you scale, to these really really huge sizes, you still have this little thing that's still missing, and it's probably something that you need to find in other modalities. Maybe you cannot model the full world that you would like to model with only text. At least that's what I believe.
All right, everyone. I am here with Thomas Wolf. Thomas is co-founder and chief science officer at Hugging Face. Thomas, welcome to the TWiML AI podcast.
Hi, Sam. Thanks for having me.
Absolutely. I am looking forward to digging into the conversation with you. We'll be talking about a wide range of topics, including transformers, Hugging Face, of course, some of your initiatives and research and the BigScience project and more. But before, I'd love to get to know you a little bit better. And one thing I found super interesting was that you did a PhD in quantum physics and then went on to get a law degree and practice as a lawyer. How did all of that come about, and how did you then end up in AI?
Yeah, how do you make a coherent story out of that? Um, no, I guess when I was studying, actually, also ML was very strong, and I was very small. I mean, I didn't even know about this field. So in France, theoretical physics was very interesting to me, and so I did this PhD. I was actually in the US at some time. Here, I hesitated between MIT and then Paris, and then in the end, Paris was more interesting for me, for the city, I would say. Um, and one of the problem I would say in physics is experiments are like super long, but we don't have any idea. When we train a model for 4 months, we're like, this is super long. But a real experiment in physics is like 4 years. You need to buy a cryostat, you need to install it, and you have all these problems. We don't realize how fortunate we are in ML that we can reproduce our experiments very very easily. Everything is quite easy to do. And so at the end of my PhD, I was contemplating going to academia, but that meant basically staying 10 years on the same topic if you want to do something impactful, and that was just too long. And at the same time, just writing my PhD was actually a very pleasant experience. And so I thought I was looking for a job where I could write more.
You don't hear that often, I don't think.
Yeah, a lot of people find that painful, like education and talking about research. I found that super interesting.
Mm-hmm.
And so a friend was a lawyer and told me that, yeah, if you want to if you want to write, you should be a lawyer. So I was like, okay, let's try. And I went up to be an IP attorney for 5 years, a little bit more than 5 years. And that was very enjoyable. I think I like this a lot. I had my pool of startups, mostly startups, but also some big groups that was helping, like with all IP question, writing patents and everything. And at the end, around 2014, yeah, something that was the beginning actually of deep learning. I think, well, at least it was starting to work, and like some startups were trying to use the computer vision models. And so I was writing the patents. I was like, yeah, this is actually a physics equation. They're just rebranded. This is they don't call that free energy, but in the end, it's a little bit the same. They're just doing the same thing. And so I decided to dig a little bit in this. And so I remember like printing the deep learning paper from Jan, the deep learning book. Just was not published yet, but there was like an alpha version on the web, and reading that. And um, and at the same time, I was supposed to move to the US, and so basically all my law degree were just not worth much anymore, because I should have like taken a law school in the US. So I was like, okay, this is a bit annoying. Don't want to do a law school anymore. Um, and so Julien was founding Hugging Face in Brooklyn at the time with Clément, and it was a game company. It was a chatbot company, and they were like, well, these LSTM stuff are kind of starting to work. Maybe we can do a bit of science on the side. And I was like, okay, I would be happy to do the science part at Hugging Face. And we had this very long dream that maybe at some point we could be, I don't know, like a deep mine, like a big research lab that seems so far away at the time. Um, and so yeah, that was the beginning of Hugging Face. In the end, I didn't move to the US. I stayed in the Netherlands, and Julien was in France, and Clément in the US. So we kind of started this remote company from the beginning, actually, and um, and this is how we started 5 years ago. So for quite some time, we were mostly doing chatbots and game. And at some point, we started to open source these few tools that we had built. That was the first one was actually some transfer learning called DeepMoji, which was before GPT, but that was, I think, the first time transfer learning kind of really worked well. Yeah, what happened is just that our open source activity got like a lot of speed quite quickly, and after some time, we were just all on the open source. And so a few years after, in 2019, we decided to pivot and to stop with the game and to concentrate on open source, which we have not regretted at all. I think it's
I
very.
bet. I'm curious. I feel like we could have a whole conversation just about kind of the Hugging Face as a business and the strategy there, and we won't do that. But I'm curious, when you think about where that all goes, like what's the direction that you all have in mind?
Oh yeah, I think I mean, the nice thing about Hugging Face is it's very, I would say, transparent company. You can see a lot of it from the outside. So and it's exactly the same in inside. So we have this very clear direction around like more open source, more open science, more like what we call responsible or good AI, which is making an AI which is not, yeah, narrowly focused, but take into account all the social impact that you have, and try to have people around the table that knows about these impacts, know about the ethical question around that. And so yeah, that's the direction. I think today there is a couple of kind of worrying trends that basically we think are things that are not so healthy, like this kind of focus on private models, on private company, the big distance between academia and like industrial labs. So we're kind of trying to fight basically this thing. And we think that's in the end, maybe much more important what you build. If we reach AGI or not, I don't know. But I think the journey that you follow, if we build a healthy community, that's actually much more important in the end. If like the research community is something where people can sit around the table, can participate together in research project, people share knowledge, people like don't hesitate to share tools, to share their results. I think that's much more important in the end, maybe than even what we build.
Yeah, I think of Hugging Face as, or when I think of Hugging Face, I think of NLP in particular, language models, that kind of thing. Um, but there's also there's tons of different types of models in the hub. How much of the company's focus and energy is specific to NLP, language models, all of that stuff versus other types of things?
Yeah, that's a good question. I think until maybe 1 year, 1 year and a half ago, that was the whole company was fully on NLP. And since last year, we've kind of been expanding first on the open source side. So we've been doing a lot of speech since about 1 year ago, when Patrick von Platten decided to push for this direction. So we have now quite a strong presence there. And more recently, we've been experimenting more with computer vision. Again, first on the open source side, and now on the research side, we also expanding what we do. Also because, well, I think we're also hitting maybe a little bit a wall in NLP, where maybe just using text alone is not enough. Even when you scale to these really huge sizes, you still have this little thing that's still missing, and it's probably something that you need to find in other modalities. Maybe you cannot model the full world that you would like to model with only text. At least that's what I believe. And so generally we're expanding. It's also easier because the tools are getting similar and similar. Everybody's using transformers. There is this kind of conversions of tooling that make it quite natural.
Beyond the open source, your team on the science side is focused on research.
Yeah. So the science team has been growing quite a lot. So mostly last year around this big science project. And now that big science is reaching its end, it's starting a couple of other projects. And the idea is basically to gather people around impactful projects. So maybe to have a research team which is quite ambitious and which can tackle kind of fundamental problems. So it's quite exciting. I think we're reaching now closer to this idea that we had in the beginning that I've always admired a lot, DeepMind and the way they can gather people around projects. And at the same time, I was always a bit frustrated that it was quite closed source and not really shared with the rest of the community. And so here the idea is to try to do the same type of research lab, which kind of select a handful of projects, but do it in a kind of open source, open science way.
And so is the big science project, is that turned out to be kind of an umbrella for uh, the kind of full breadth of your research program, or is it a specific project and you have other projects exploring other areas?
Yeah, so big science project is a specific one. So it started pretty much 1 year ago, a little bit more, and the discussion was around a good relationship we had with compute cluster. It's always good to have a nice relationship with the neighborhood compute cluster. So there is this big public compute cluster in France called Janzé, which is quite big actually. It has more than 3,000 GPU. And they were like asking us, they were a bit like underused, and they were asking us, okay, can we do something together? Do you want to use the cluster for something? And so at the same time, like people were kind of releasing this series of large language model. Well, I mean, releasing the paper at least. And I was like, okay, that would be nice to make maybe a large language model that would be public. Um, and so we could do that there. And the more we were thinking about it, the more we thought it's a bit annoying to do that just Hugging Face, because we'll just reproduce something that we think is missing today, which is just like we just do the same that people are doing, which is like having 5 people in a small like team training. But the way we think this should be done is more like what I've seen when I was doing like my PhD, which was this very large like physics collaboration. So the example I take often is the LHC, which is this huge hadron collider, which is in Switzerland, that costs like $10 billion. And so obviously $10 billion, that's much, and that's really outside of the reach of any university lab. So how people do that in physics? They just get together a bunch of research university, a bunch of research lab, and then they basically ask a big grant of 10 billion. So thankfully, we don't need 10 billion to train a language model yet, maybe in the future, but you kind of need 10 million, which is still quite significant. And so I thought maybe we could do the same. Maybe we could just gather a lot of research labs together from industry, from academia, and then we ask a public cluster to give some hours. And it turns out you can do that, and that worked. Basically, we asked them 5 million GPU hours, and they'd say yes. There you have them. We actually asked them everything that they were supposed to grant for 6 months, and so the conclusion was that they made the cluster itself bigger, which is also a nice outcome, because then the cluster will be bigger for all future research. And so the Big Science project started then 1 year ago around this big grant of compute time from Janzé, from the Janzé supercomputer. And then we had everything to do to build a large data set to gather. The idea was to gather around the table people from social science, people from like data, people from modeling, people from also maybe other fields that would be interesting using a language model, like historical documents, biomedical people who want to maybe use them. Everybody who could be interested in using a large language model should be able to join the table. And so today there's, I think, a little bit more than 1,000 researchers who are like signed the participation form to Big Science. So not everybody is active. Obviously, that's like a voluntary basis, but I would guess maybe 200 people are daily active on this. And we are now reaching the last stages. So we finished the big data set just last week, which is 800 gigabytes. Um, and we are starting the training probably next week, which will go for 4 months. So that's quite long to train these beasts.
What does it mean to have 200 researchers working on curating this data set?
Yeah, I mean, they don't all work on the data set. The data set, there's also the model to build. But yeah, I think it's very surprisingly great because, um, more and more we see that these models are only as good as their data set are, basically. Huh? They're just kind of a reflection of basically the data set that you feed in. And most of the time, a part of this data set are like crawl data, for instance. But here, just because there are so many people there, we could have like a kind of crowdsource of the data set. So we ask all the native speakers. So this is a multilingual model that we are training. And we ask all these like native speakers to select good quality source in their own languages. And because there are so many people, when you gather all that give you like 800 gigabytes, which is enough to train this huge model, actually. So you don't even need to crawl the web, basically, to get that, just because of the power of community, I would say, somehow, of at least a large collaboration.
What gives you the confidence to say that now before you've actually trained the model?
That's right. You got me there. We still need to train it. But I think the data set in itself is actually also a super interesting artifact.
Hmm.
A lot of work was also spent on the legal aspect and the governance aspect of being able to share this data set,
Hmm.
because that's a crucial resource that's missing today. If you even if you have access, I don't know, to GPT-3 or some of this model, you never really have access to the data set. And that would be super interesting for a lot of research if you want to know if you're actually doing few shot, if you want to know if your model is good there because it was like 10 times or 100 times or 1,000 times in a training data set. If you want to do, I don't know, PII research. I mean, for a lot of research, it would be super useful to be able to dig in the training data set and know what the model has really seen. And so being able to have like a very large multilingual data set is a super valuable resource already. I think sometimes we focus a lot on models, but data set, they live longer actually than the models. But yeah, now we still need to train the model. That's right.
Recognizing that you haven't trained the model yet, I'm curious how you think about this approach to curating these data sets and like how you think it's going to play out in terms of the model. And I think the analogy that I'm constructing is, with deep learning, we've kind of said, hey, instead of like, curating this data set and, uh, doing feature engineering and all this kind of more manual handcrafty kind of things, let's just throw a bunch of data at a sufficiently large model and, it'll figure out the patterns that it needs to provide value to us. And I think I'm drawing an analogy to, hey, let's just slurp up the entire web and train a model, and it's gonna, that's gonna result in good things. Now we know some of the downfalls of that, like the web, lots of corners of the web can be a bad place. And I'm curious, like how you think it's all going to come together, relative to the way we're creating these models today.
Yeah, I mean, there's a lot of aspects which you're asking. That's a very good question. I would say first, I think we kind of come back a little bit from just scrapping the web and just feeding the models with that. And there's actually a good lesson in BigScience, because to test the scaling in the beginning, we trained a 13 billion model just on like a bunch of common crawl data. 13 billion, yes, which is already quite big, I would say. Huh? That's probably bigger than a lot of. Is there a 13 billion open source? Well, there is the 20 billion now from Eleuther since 2 weeks ago, but that's quite big. And the performances were pretty bad actually. And when we tried to dive in it, the reason was the data. If you just take common call like this, it's not very high quality. And so we compared with other like manually selected data set like the pile, or like another set of common call, and all of the pointer were just that it was all about the data that was not highest quality. And so I think we kind of come back a little bit from that. There was also a bunch of research around like how when you just deduplicate your data set, you actually improve the performances of your model like drastically. And if you look at even, like GPT-2, GPT-3, the data was still quite carefully selected from links on Reddit or things like that. So that kind of sounds like a bad place on the internet, but that's still quite a good indication of good quality. So I think this is now more and more people consider that very important. a similar thing around the training data set of like clip or thing like that. People have been really struggling to reproduce the performances, and that's mostly from the quality of the data set. I think OpenAI is really great in carefully curating high quality data sets. That's something that they have very well perfected.
Meaning this thing that we think of as like we're going to slurp everything and create a model is not actually what's happening. It's a lot more carefully curated than that.
Yeah, that's what I think. Yeah,
Mhm.
definitely. But then on the other hand, there is also the question of how you evaluate the model. And
Mhm.
if you want, obviously, if you want, like, for instance, to evaluate your model mostly on, I don't know, benchmark that are made from Wikipedia data, you probably want to tailor your model around this distribution. And so in BigScience, we've made the choice of trying to have a data set that is representative of what people are actually reading on the internet. Uh, so there's diversity of source, but some of these sources, they are nowhere in our evaluation benchmark of ML people, right? So these are like modes of the data set that the model is learning for nothing in terms of evaluation. Uh, but we think this is actually more important, that the data set somehow is representative of like what a human is accessing, maybe more than the benchmark of today. But that might means that it might underperform on some benchmark because it's not really tailored around these benchmarks.
Can you talk a little bit more about the evaluation part of the process of the training process and kind of how you do that at scale? You know, when we're talking about language models.
Yeah, so on BigScience, actually, that's one of the parts I did not follow much. There's so, so many parts. So I follow mostly dataset and model, and the evaluation was also a huge area. So a lot of this, so there are like a little bit more than 40 working group in BigScience. Most of them are about like at least 40, 60%. So there's a lot of activity. A lot of them are actually submitting papers, and there is a lot of side research on evaluation. They have been also doing a lot of research on evaluation itself. So yeah, I think on this, the best would be to read the paper that they have been just submitting. I think last month there was a couple of papers submitted, and they are also writing some today on bias. I was seeing that, but yeah, I won't be able to give very good feedback. Maybe I can just say that we've been using the EleutherAI harness mostly for our tests, which is, I think, a great framework. So just a quick shout out to them. Good work on this.
Okay, nice. And so, speaking of Eleuther, they're another kind of distributed group that's trying to create open source language models. You know, how do you differentiate what you're doing with big
Yeah.
science? You know, besides from the community dynamic that you're trying to create and the process, is the expected result, you know, going to be something that you think of as comparable, or are there more fundamental differences in the way that you're thinking about the problem?
So I mean, there is a lot of interaction. I think many people from Eleuther are very active. If we look at the papers that have already been out from Big Science, you will see there are Eleuther papers. Stella is very active, but there is also a lot of them, Leo, and so there is really like a big overlap, and we try to share like knowledge. I think the main difference. So one will be that we were from the beginning targeting a multilingual model. I think that was important for us because one aspect that I find a bit frustrating is that there is this super strong dominance of English in this field right now, in the large language model field in particular. Maybe Chinese as well, if you want, but yeah. And the other aspect is really that we try to make a project, a workshop where we could have a lot of academic people. So from the beginning, we were thinking, okay, how can you build a collaboration where academics can participate along with industrial? How can you align all these incentives so you have together a team from deep speed people? They are very involved, they are doing really great work. Nvidia people, so Google people. So for instance, the evaluation part is a lot driven by some Google people, Facebook people as well. That's probably actually the first project where Google, Facebook, Nvidia, Microsoft are all training a single model together. I don't think this has existed in the past, or either. So we were thinking a lot, okay, how can you align the incentive of all these people so that they can participate together? So yeah, I mean, that was a difference in kind of the meta direction, meta approach or goal that we wanted, or that at least I found important. But overall, I think it's nice if we have a couple of open source model. I would find this a bit annoying if we have just one, and then people will start overfitting on this artifact and thinking that, I don't know, some weird thing they have seen is a general rule, while it might just be a random coincidence, you know.
Nice. And so big science has been a big focus for you, but in terms of other activities of the science team and research group, you mentioned multimodality as an area that you're interested in. Can you talk a little bit about what you're doing there?
Yeah, I think that's kind of a natural extension somehow, right? When you see that, even when you scale this text model, there's still a little bit of things missing. You want to extend to other modalities. So one of the projects we would like to tackle now is like a bit the same multimodality, and here the same. I've seen that there's a lot of models coming out in the recent month from a lot of companies, and most of them we see the same problem, like the data set are private, the model tend to be private. So I think here again there is kind of a need to come and to say, hey, maybe we can share things more, maybe we can build on the shoulders of each other. Um, but more generally, I think this kind of scaling that we've seen in NLP should be applied and interesting in other domain as well. I think this kind of zero shot performance, we would like to see them also in vision. We would like to see them also in speech. And so that's the area we want to explore in the coming month. And kind of related to this is the extension to when you have multimodality at some point, you would like even to interact. And so embodied environment is the natural extension. And here also, I think this is very exciting area. And maybe today is a good day to start tackling this, I think.
And today, because we're all talking about metaverse and things like that, or
Yeah, no, not really. I mean, I like the idea of the metaverse. I'm a bit afraid it might be kind of Facebook only. Then it make this a bit less collaborative community endeavor.
uh
But I think the general idea of using virtual environments or things like that are interesting. Also because I'm always very frustrated how this model learn language so differently than us human, right? We learn language in action, we learn language in situation, with like all this kind of multimodal and even interaction. And I think at some point, if we could bring the way we train this model a bit closer to the way human learn language, we might also be able to solve this kind of inconsistency that we get when we don't really understand why the model is failing here. And so that's probably a direction. But more generally, I think also just simulation and synthetic data are interesting on many aspects. So, for instance, when you think about bias and like PII and on all things, if you could build your data set yourself and control it, and at the same time having a diversity which is wide enough to learn the concept that you want reliably, it would make a lot of like ethical and social aspects easier, in my opinion.
do you have projects, like active projects around that? I'm curious how, in practice, how you go about doing that.
The embodied, the virtual environment one,
No,
or
no,
the multimodal.
the latter, the I wanted to dig a little bit deeper into kind of constructing these data sets such that they are sufficiently diverse,
Mm.
capture what you're trying to do, but also, unbiased. And I'm thinking about, yeah, I'm just wanting to learn from your experiences there. If it's something that you're actively working on, are there, techniques, tools, things that help, can help someone do that?
So as often I'm maybe I'm more like a naturally I'm more like a builder of tools. I mean, even BigScience
Uh-huh.
is just kind of a very big tool for the community, in my opinion. That's just it. And the same for virtual environment. I think today it's very difficult if you're like an NLP researcher and you're like, hey, I would like to do some grounding. It's really scary. You need to like use totally different tools than the one you used to. So for instance, you need to switch to, I don't know, Unity, learn C sharp or even C++ if you want to ground on Unreal. So there is like this huge tooling gap, I would say. And tools are important when you saw, like, I don't know, like PyTorch or TensorFlow, things like that. They're really enabled research in themselves. If we didn't have them, we would be like still really light years in the back. So I think right now there is this main problem here. Like if you want to create synthetic data or virtual environments, it's very difficult to do this and to do it in a flexible enough way. So that's the first step that we are doing right now, trying to make a tool around this.
And do you see that as primarily easier interfaces for researchers and ML people to interact with, or simpler environments, kind of ground up, meaning, some kind of way to make Unity, something with Unity's level of richness, easier to use so that they don't have to do C++, or is it, coming up with a simpler model that, still exercises the idea of grounding and embodiment?
Hmm. Yeah, I don't have the answer yet because the problem is still we have this first version, but they're very early. But I
Mhm.
guess in a few months, you will see the answer. Hopefully, if everything work well. But I think it's a mix of both. Ideally, you would like to be able at the same time to, or in kind of a similar setup, to try your model on simple grounding. You want like to try on simple, I don't know, 2D world or even text world. And then if you want to scale to like Unity, you would like to be able to do that quite simply. And at some point reach maybe even photorealism and transfer. But along the way, there's a lot of also research problem that are still open. So the question also that you were hinting at, which is, do we have today like a synthetic environment where, for instance, you can train a computer vision that can match ImageNet performance on of a ResNet trained on ImageNet? I don't think today it really exists. So this is more, in my opinion, some things we still don't know exactly about how to measure dataset diversity and how to know exactly what is the diversity we need to have.
Maybe more fundamentally, when you think about kind of embodied learning, are you thinking about it from a language and NLP perspective primarily? And what does embodiment mean in that context? Like when we're talking about, reinforcement learning and control problems and robotics, like, that grounding connection is clear. When we're talking about like grounding text in, images and things like that, that's clear. What changes about uh an NLP or a language model or something like that in a agent type of environment that, fundamentally creates grounding?
Yeah, that's a good question. Well, I mean, there's a lot of view to see that, and I don't think anybody has a real answer. But in my opinion, a lot of things we're missing is kind of this interactive thing around in the world. So it's both being in the world, but also being interactive with another agent or human. Like you can have either human loop or another agent. So it's like learning. It's like this usage-based kind of way of learning language, which is really at least how we human learn language, which I think is one of the reasons you see kind of this weird effect with this language model that they have a little bit of problem with theory of mind, like discoupling their own uh, universe with the universe of somebody else because they never had kind of this interactive learning that you could have. So some people are training more in text, right? You could learn also in dialogue, just pure text. But in the end, you know that when you're talking about an apple, there is like also an object, which is the apple. So if you can ground that also in this object, that would be even better.
So it sounds like a big part of the idea around embodiment is just, it's about like multi-party interactions, and creating data sets that are kind of natively dialogue based, as opposed to embodiment somehow necessarily grounds, yeah, like single party embodiment, like grounds language or something like that.
Yeah, no, I think as well. Yeah, it's a lot about grounding in interaction, and then the big question is how can you make that efficient, right? We know that RL is like really not data efficient. We know that well, so there is all these interesting questions that are connected around me, which is around this, which is the development of now some form of offline learning in RL that starts to work maybe a little bit. All this idea around maybe being able to do transfer learning. I also think we often associate like virtual or simulation environment with RL, but they can also very much be used with supervised learning or unsupervised learning like we do here. You don't have to have like just a scalar reward. You can have a lot more information. So I think we start to break. That's I think what is super interesting. Maybe the end of last year, beginning of this year, we see a lot of bridges that are breaking between NLP and vision, between maybe RL and NLP and vision, and that's super interesting. I've not seen that for yeah, I've never really seen that in AI or ML field. That all these people are switching so easily. You see NLP people starting to do the computer vision. You see RL people doing embodied learning with like interaction and NLP.
And you mentioned the convergence of tooling, in particular transformers, as being a big driver of that.
Yeah, and the simplicity of the transformers paradoxically make us more interested in data and environments and complexity and diversity, which is really in the end what's matter. So
Mm-hmm.
we also stopping a little bit with all the architectural complexity we were adding on top of our LSTM and going back to a
Yeah.
very simple architecture. And so we can focus now to maybe things that are more important, which is what is our training procedure and what is actually our inputs and yeah, all these questions.
Are there things that you've come across that you find to be like the harder parts of really understanding transformers, or things that like folks don't sufficiently understand, in your view, or things that surprise people when they learn?
I think transformers are actually much more simpler to explain than all the LSTM or RNN that we had before. I think the, well, I mean, just like everybody, I guess the first time I was reading Transform paper, I was like, "Oh, this is super, super complex." But now, if you start playing, if you code one yourself, you're like, "Oh, this is actually a very simple architecture
Yeah.
in the end, and it's getting simpler and simpler." Yeah, but I think what most people are still kind of missing, but we also see the shift today is this shift to what I was saying, data, right? But Andrew Ng and people like that are also pushing and saying, "Hey, data centric." But I really think it's something we need today to pay more attention to this part of the pipeline and to this part. And here we're still lacking tool also, according to me. We're lacking data measurements tool. We're lacking, often when people put out a data set, they mostly say, hey, it's like X billion tokens. And here is a rough idea how I gathered it, and that's it. But if anybody was like publishing a model and just saying, hey, it's like X billion parameters, and here is a rough idea of how it was trained, but I didn't evaluate anything, I didn't do any measurements, and that would seems really strange. But that's kind of what we do today with data set. We don't measure them, we don't really analyze them. So that I think here there is a lot of room to build interesting tools and interesting insights.
There have been some efforts in that direction, like the data cards for data sets and things like that. Sounds like you're talking about more concrete tools that you download and point at your data set, and they
Yeah, so
tell
Meg
you something
Mitchell,
is.
yeah, for instance, there was this effort last year with Meg Michel, Sasha Uchioni, Yassine, Angie at Hugging Face on building a data measurement tool that kind of tried to give you insight. But that's really the beginning. I think this could be developed a lot more. Uh, yeah, I agree very much here with you. Yeah.
Mm-hmm. Is that tool? Can you talk a little bit more about that tool and kind of what it did and where its edges were?
Yeah, so it's a tool where you can input your data set and it gives you a lot of different metrics or like evaluation of your data, and you can also use that to compare two data set together. So you have some aggregated metrics like the zip load. This is like the most frequent words, and this kind of help you to know, is your data set kind of following, I don't know, standard English, or is your data set kind of strangely biased? You have tools to see some correlation between words, and you can see some, for instance, biased information. Is male always correlated with doctor, or this kind of thing, or like more complex? You have also very simple thing that actually people don't do much, which is just looking at the duplicated example. And when you take many common data set, I don't know, like squad or thing like that, you see that there are many duplicates actually, and just this simple thing should be a requisite to investigate why do we have duplicates or strange entries. You have tools around perplexity. That is a way to tell a little bit maybe where what domain is your data set, which kind of domain it's more on. But then it's just the beginning, and the idea is to add more metrics and to also contextualize this because it's a bit new. So when you see, I don't know, that on this kind of data set metrics have this score, what you would like to understand is this good or not? Is my data set actually wrongly selected, or does it have some problems that I don't understand or not? So I think there's a lot of work around also contextualize this and basically generally education, understanding how you can understand your data. If you look at the data measurement tool, that's the first one that came out.
Got it. Got it. So I'll get those links from you and we'll make sure to include them in the show notes page. I also wanted to ask about what you're working on in the retrieval space from a research perspective. How are you thinking about those problems? And
Yeah, so this is also super interesting. That's also a major frustration with today's model, right? So when you take, I don't know, the one, so for instance, we've been talking about GPT-3. It still doesn't know really about COVID, and you're like, well, it should be really nice to be able to update this model because that's a huge part of our life. And the same with BERT, which still think that Trump is president, and so. This model are like this static thing, and we would like to make them able to evolve. And retrieval is one way. I think today it's maybe one of the most interesting, but there are other way. So yeah, this is one way to both being able to make your model learn some things, and also to have some maybe better understanding on how your model produce its output. At least you can have a little bit more information by knowing what it was querying in the database. I also think today we do a lot of retrieval in NLP, but maybe it could also be just like what we've been saying, it could also be maybe interesting in vision or like other fields as a general way to retrieve some kind of static memory, or at least something that the model can use as an anchor point. So yeah, so we have a couple of people. Niels Reimers is mostly leading here. And then there is a couple of interns mostly at the moment working on different topic there.
is your model from a research perspective kind of along the same lines or along the traditional, publish lines, or are your, how do your goals, differ based on where you are? It sounds like a big part of it is, producing open source data sets. I imagine producing open source, models and other things as well as a big effort. Is that in addition to publishing papers? Is it, does it swing a little bit more towards open source than papers? Do you think that's the right way to do it? How do you think about the whole space?
Yeah, no, that's right. That's something I spend a lot of time thinking. I think the focus on papers is good on some aspect. With like there's some serious thing when you write a paper, you like go back to the literature, you cite relevant work, but there is also a bit of overfitting, right? When you just write a paper to just write a paper for this deadline, and you need to I know to have a paper. So at Hugging Face, because we think that tools are as important as research basically, and that they can go together, we focus more on like general notion of an artifact. So maybe at the end of your research what you have produced is a model, maybe it's a data set, maybe it's a paper, or maybe it's a code tool, or maybe it's even just, yeah, it could be some reflection, or like something around, I don't know, the ethics or the social impact, or something that could be in a blog post and that could have a huge impact. But I don't think you need to have a paper to have huge impact. I think these are more like side product of what you're doing actually. You're doing something, and at some point you're like, okay, let's write a report, and oh, we have this deadline, we can submit it there in this conference. So we focus more on what you producing, like kind of impactful artifact out of what you do as a research, more than producing papers. It lets you also, I think a bit longer. If you want to make a 1 year project, um, it's a bit strange to think in terms of a 1 year paper. That's a bit depressing, maybe even. So
When you think about, how far the companies come from chatbots, there's kind of at the same time that uh, NLP broadly has evolved tremendously and is now you know, greatly impacting other areas of machine learning. Like, where do you see it all going? You know, when you think about, you know, natural language understanding, generation, you know, all of that stuff.
I don't know. I really feel like we are at the beginning again of like something. I was thinking about that this year. Yeah, I think there's so many open door. I think, yeah. So obviously we had to make. I remember we had to make a choice, and when so Victor San is one of our lead scientists, and when he joined, he was like really strong in computer vision, and I told him, yeah, let's try NLP. This is this kind of understudied field, but that's also nice. Uh, and now I'm trying to do the opposite. I'm like, now you're really into NLP, but let's extend. Let's come back to computer vision. It's also nice, but I think computer vision. There's a lot of things you can do, and the most interesting, I think, just like NLP, are just about reinventing the field and thinking, hey, we're training on these fixed 2D images, but is it actually what we would like to do as a vision object detection or like kind of thing? Do we don't want to more like try to understand the 3D world, for instance, outside, or even 4D with like things that are moving? And so, what is very interesting, I think, today is stopping and say, hey, maybe we need to reinvent this field and stop. I should just stop maximizing my metrics on this benchmark, but I should maybe reinvent the benchmark itself. And is it really? So the same is happening in NLP, I think, with like this blurriness between these tasks that were historically very separated. You had like test classification or question answering of these things that were very separated. And with this large language model, you have one model that kind of tackle all these things and that kind of question your the boundaries between even this task. Does it really has a sense outside of the data set that you're using? Is your task actually something that's really well defined? It's less and less clear, but that's even more interesting because then you ask maybe more fundamental question around why you why you do NLP in the
Right.
beginning, right?
Yeah, maybe to close out, I want to give you an opportunity to talk about your book. The book you co-authored, Natural Language Processing with Transformers. I think it just hit virtual bookshelves a couple of days ago as we're recording this.
Yeah,
Is that
that's
right?
right. Yeah, that was a process long in the making. So it's really a lot of the work is Lewis and Leandro's work. They've been really the one like starting the idea for a long time. I was people were asking me like I mean publisher was saying, hey, you should write a book, and I was like, no, it's too much time investment. It's really and Lewis and Leandro came and say, hey, we've already wrote a chapter. Can you read it? What do you think? Do you want to join as an author? And I read the chapter. I was like, yeah, that's actually like really interesting. I like the way you write. And so we started that now 1 year and a half ago, like spreading the chapters between each other. That was very long. We wanted to make this in the way that we've loved to read recent book, which is book with like also code notebooks where you feel like you're actually learning at the same time kind of a fundamental question, like for instance, what is good evaluation? How do you work with like few data set, few labels, or even zero shots, like this fundamental question, but also at the same time that you feel like you've implemented something. So every time we like take a data set and kind of work together, like tackling all the problems. And even at the last part is like training a very large language model, and we also like build data set together from GitHub and make a code, kind of a copilot or like a code parrot, we call it, together on how you scale this. So it ranged from like very small language models like Distilbert, very efficient, how you quantize them, to like very huge 1 billion parameter model that's trained on code. So yeah, I'm very happy about the results, and I'm super excited. I'm the only one who didn't receive the physical copy yet, so I'm still kind of waiting to get it in my hand and feel that it's real.
I
But
tried to order one, and unlike I don't think I've ever seen this before, but it's like a prime book, and they said uh you know, the delivery time was long. Like, you know, you'll get it between February 24th and March 5th.
oh
um
yeah, yeah, that's
Hopefully
possible.
that's because like it's in hot demand and they can't get enough copies from O'Reilly.
I hope as well. Yeah, we don't know yet, obviously, because we don't have the first numbers. But I mean, anyway, I'm very proud of this book. I think
Hmm.
this was a very great collaboration. And actually, after the during the collaboration, Lewis and Leandro joined Hugging Face as a
Nice.
consequences. And Lewis has been now working on the course, because we also have a course at Hugging Face, which is kind of a, well, it was not written at the same time as the book, but the idea is a bit the same, but really more code oriented. So it's really how to use all the ecosystem, all the data set transformer.
I've heard really good things about the course and the way it's organized.
Yeah, yeah, I think it's great. And the last part is also being finished now, which is more bit more extended. But all the 8 chapters that are out now give you a very good grounding if you want to start like using all these tools. Yeah.
Did I read correctly that the book was written using the kind of fast AI tool chain that Jeremy and Sylvain use for their
Yeah,
book?
definitely. Yeah. So, I mean, Sylvain is also working at Hugging Face, so definitely this is a all these people know each other, and we are very great admirers of what Jeremy has done. So
Yeah.
yeah, we use this same thing, the NVDev and the notebook environments, and it's
Hmm.
nice because now we can have all these notebooks, all these collab that are directly outside to play with.
Hmm. And one more question on the book. The O'Reilly's known for these animal covers on their books, and this one is a parrot. Is that a nod to the Stochastic Parrots paper and Meg? That Meg's a co-author on.
Yeah, no, that was the best surprise of the book, right? Because you can't choose the animal, you have no
Oh, really?
choice. Yeah, and when they
Mm.
said, "Yeah, here is your animal," I was like, "Oh, that's really great," uh, and that's the reason we decided to name the so this big code model that I was talking about, the 1 billion that we trained together in the book in the last
Hmm.
chapter. We decided to name it Code Parrot
Hmm.
because that's what these models are in the end. That's
Hmm.
at least today.
Hmm.
Yeah.
Awesome. Awesome. Well, Thomas, thanks so much for joining us and sharing a bit about what you're up to and thinking about and working on.
Thanks. It was a pleasure.